Okay, so now I want to show you some of the equipment that we're going to use and maybe set up and show you how to take some data. So this yellow box is the capacitance substitution box. The ends of the capacitor are this black and this red terminal. And then you have an array of switches. And whatever switches, the switches all have capacitance values. And essentially you add up all the switches that are engaged. An engaged switch is switched down, so that you add up all the switches that are down. The resistance box over here works very similarly. The ends of the resistor are the two green terminals now. And now you have to switch the switch up. So the resistor and the capacitor boxes are different in that regard. So I've already done the calculation. I want to make my break frequency 2,000 hertz. I think the lab says 4,000, but I want to make it 2,000. And so I've sort of randomly chosen the resistance to be at 4,000 ohms. That's that button right there. Everything else is down, but the 4K is up. And I've done the calculation. So omega is 1 over RC. I've chosen R to be 4,000. Omega is 2 pi f. I've chosen f to be 2,000 hertz. And when I do the calculation, which you should repeat, I get that the capacitor should be 0.02 microfarads. And so I have that switched on here. Over here I have a multimeter that I can use to measure precisely what the resistance actually is. And I also have this capacitance meter which I can use to measure the capacity of the capacitor. Let's do that. So now I'm going to measure the capacitance of the capacitor using the capacity meter. You just plug the capacitor into the meter directly. Find a level, a setting that gives you the most sig figs. That's overloaded. That gives me 3 sig figs. That gives me 4 sig figs. It's 19.5857 or 58 nanofarads, which is 0.01958 microfarads. So that's what I wanted it to be. And when you see the data sheet, that capacitance will be labeled on there. Great. So now we're going to measure the resistance of the resistor. So here's the two ends of the resistor. We put them into the proper inputs of the proper inputs here of the multimeter. Turn the multimeter on to measure resistance, and I get a reading of 3.98. That's kilo ohms. So 3,980 ohms is our resistance, and that'll be recorded on the data sheet I sent you. Okay, now we know our resistor and capacitor. We're going to hook them together in series. And then we're going to drive them with a signal generator. Here's our signal generator. Hang on a second. Here's our signal generator. Let's see, this wire's in the way. So we can set the frequency using these switches and this knob. These are not important down here. This is a voltage, high voltage, low voltage, so it's set to be high. Basically, the only other things that are important is the amplitude knob here. And this is the output, the sine wave output comes out right over here. And I want to talk a little bit about the sync. The sync sends out a pulse once per cycle, synced to the output here. And so I'm going to use that to trigger a frequency counter that I have up above here. So this is going to give us a precise readout of the frequency. I'll actually turn them both on and show you how it works. So as I adjust the frequency by turning this knob, you can see the readout of the frequency changes, and it gives me a good robust 4 sig fig reading of the frequency. So that's great. So now my signal generator, out of my signal generator, the high side goes to the resistor. So that's that. Then from the resistor, other side of the resistor, I go to the capacitor. And from the capacitor, I go to the low side, to the ground of the signal generator. So now that I'm plugged in, let me show you that again. From the high side to the resistor, from the resistor over to the capacitor, and from the low side of the capacitor then back to the low side of the signal generator. Over here we have 2 voltmeters. They're going to be AC voltmeters because we have an AC signal. So they're both set on AC volts. They're really multimeters, so AC volts. And then I set a scale range. The input for the voltmeter are the red and the black. The top and the bottom are identical. With one of them, the top one, we're going to monitor the RMS amplitude of the input voltage. So for example, now it says it's 5.24 volts. And then with the bottom one, we're going to look at the voltage drop across the capacitor. You got to be careful not to cross grounds. The low side of all these devices that are plugged into the wall, the low side of all of these, they're all connected to the third prong of the plug. So they're all internally connected. That's why it's called a common ground. So now I've got the bottom voltmeter connected across the capacitor. This now should be a low pass filter because I'm looking at the output across the capacitor. I think I set the breakpoint to be about 2000 hertz. Notice when I drive it with a low frequency, so 847, the input and the output voltages are pretty close. 5.26 volts in, 4.85 volts out. On the other hand, if I go up to a very high frequency, like here's 18,000, so well above the breakpoint, then my input voltage is 3.22, but my output voltage is very small, 0.11. So this is the idea. As I go to lower and lower voltages, more of the voltage appears across the capacitor. So what I'm going to do now is just take a bunch of data, in fact I've already done it, of frequency, input voltage, and output voltage. Here's what that data looks like. So it's, you can see it's frequency, input voltage, output voltage. There's the circuit, there's the capacitance and the resistance. And I will scan this data in and give it to you. Then finally, we have to swap, we have to trade places between the resistor and the capacitor. And the easiest way is to literally just pull the plugs from the capacitor and put them in the resistor. I got too many wires here. And pull the plugs from the resistor and put it in the capacitor. And I should be set up now for the low pass filter. I actually, when I did the high pass filter, I changed the resistance up to 6,000 ohms. So the resistance is different, the capacitance is the same. And again, I vary the frequency, measure the input and output voltage, and I get some data that looks like this, which I will scan for you and send to you. And I think that's basically all that you need to know. So I'll sign off right here.